Hello everyone, this is BB Hiramat. Today I will going to discuss the concepts of total internal reflection. That is one of the important part of the ray optics. Let us consider two mediums. One is a rarer medium, another one is denser medium. And this line is considered to be a interface. Interface is nothing but it is a surface between the two medium. And this is the denser medium of its refractive index is N1. This is the rarer medium of its refractive index is considered as a N2. Let us consider an object O which is present in the denser medium. Then this object is illuminated object. If it is object is illuminated, then that emits the rays as shown like this. In first one, the ray OA that passes from denser medium to rarer medium without any deviation, because this line is normal to interface. And this is a second line OP. So that OP is a ray with an angle of incidence I, and that ray is refracted and bent away from the normal line as like that. So the third ray is OQ. So OQ is a ray of its incident angle or angle of incidence that is equal to C. In such a condition, the ray which grazes the interface, and this angle of incidence which is called as critical angle. What is critical angle? A critical angle is nothing but a particular angle of incidence. The corresponding angle of refraction is equal to 90 degree, and this angle of incidence we can call it as critical angle. The last ray here, that is OR. OR is a ray which like this. Here the angle of incidence of this ray that is more than that angle of incidence of the OR ray is greater than critical angle here. In such a condition, the ray is reflect back to the denser medium only, and this is what we can call it as, this phenomenon we can call it as total internal reflection. Once again, what is the definition of total internal reflection? That is, the total internal reflection is a phenomenon in which the ray should be travel from denser to rarer. Now definition is like this: when a ray of light traveling from denser medium to rarer medium of angle of incidence is greater than critical angle, in such a condition the ray is reflect back to the denser medium. This phenomenon we can call it as total internal reflection. And the critical angle definition like this: the particular angle of incidence, the corresponding angle of refraction is equal to 90 degree, and this angle of incidence we can call it as critical angle. So this is about the total conditions for total internal reflections are like this, in which first one is the ray should be travel from denser medium to rarer medium. So this is a denser medium, and this one is rarer medium. See, there are two conditions of total internal reflection, in which first one is the ray should be travel from denser medium. This is the denser medium and this is the rarer medium. The ray should be travel from denser medium to rarer medium. The second one is the angle of incidence should be greater than critical angle. Then only that will get the total internal reflection. This is for a given pair of media and given colors. Next derivation is the relation between critical angle and the refractive index. See, let us consider two medium here. One is a denser medium of its refractive index N1. Another medium is the rarer medium of its refractive index is N2. When a ray of light which is traveling from denser medium into rarer medium here, see, and this is an angle of incidence which is equal to critical angle, If when a ray of light that is traveling from denser medium to rarer medium and angle of incidence is equals to critical angle, in such a condition the refracted ray which grazes the interface. Nothing but, so this angle of refraction is equals to 90 degree. Then according to Snell's law, that is the ratio of sine of angle of incidence, sine of angle of refraction is equals to n2 divided by n1. According to Snell's law, that is the ratio of sine of angle of incidence to the sine of angle of refraction is equal to constant, that is n2 divided by n1. This is the Snell's law. So on cross multiplication it becomes, this equation becomes, that is n1 sine I is equals to n2 sine R. We can write like this, and so n1 keep as it is, sine I means angle of incidence, that angle of incidence that is equal to critical angle here, hence this becomes, instead of I we can write it as a C, that is equals to n2 keep as it is and sine R is nothing but angle of refraction, that angle of refraction is equals to 90 degree, hence it becomes 90 degree. Then n1 sine C is equals to n2 sine 90 degree, and sine 90 value is 1. Sine 90 value is 1. Instead of sine 90 you can write it as 1. It becomes n1 sine C is equals to n2 into 1, or is nothing but n2. Then C is equals to, so n1 becomes n2 divided by n1, and sine here, so if it is moved to RHS side it becomes sine inverse, hence totally you can write it as sine inverse of n2 divided by n1. So this is the relation between critical angle and the refractive index. If there is a given like this, if the denser medium of refractive index is considered as n, denser medium of refractive index is considered as a n, that is instead of n1 it becomes n, and the rarer medium is considered as a air medium or vacuum. In such a condition the refractive index of air or vacuum is considered as a 1, hence the above equation becomes C is equals to sine inverse of 1 divided by n. So this is the relation between refractive index and the critical angle. So according to this relation, as the refractive index of the medium increases, then the critical angle is decreased. Nothing but the higher refractive index medium that should have lower the critical angle. So this is the relation between critical angle and the refractive index. Applications of total internal reflections are like this. In which one? First one is brilliance of diamond. The brilliance of diamond is possible by proper cutting of the diamond and the total internal reflections in it. Because of that reason, so the diamond is appears like a twinkling or brilliance. Why? Why means here the diamond is a high density material, nothing but it should have high refractive index. Because of high refractive index, we know the relation between refractive index and critical angle. So the refractive index is more, obviously critical angle is very small. The diamond having refractive index that is 2.4. Hence, the critical angle value is very small. Its value, critical angle is approximately equals to 25 degree. So because of this reason, once the ray of light which enters into the diamond, and along with that the proper cutting is should be needed. Proper cutting is needed. Once the ray of light is entering into the diamond, so the critical angle value is 25 degree, that is 25 degree, very small value. Hence, so if the angle of incidence is more than critical angle, obviously the total internal reflection is happens inside the diamond. So proper cutting of the diamond that leads to multiple total internal reflections, and the series multiple reflections, total internal reflections are made inside the diamond that leads to cause the diamond is appears like a brilliant, or diamond is appears like a twinkling, or a, which is appears like a shining. That is the reason behind the twinkling of diamond or brilliance of diamond. First one. Then second, come to the second one. Here mirage. See, mirage is an illusion which is observed due to total internal. We know that refractive index increases with the density. So hotter air having less density. So hotter air which is near to the ground having less density, hence its refractive index is less, and the colder air, nothing but another higher level air which is high density one as compared to so ground level air. That's why the refractive index of the higher level air is more. As like this, so the the conditions, as per the conditions of total internal reflection, which is the ray should be travel from higher then the refractive index to lower refractive index, or a denser medium to rarer medium. Like the same concept here, the ray is traveling from higher refractive index denser air to rarer medium, denser medium to rarer medium. So here the ray of light with the from the object that is traveling from denser medium to rarer medium now. So because of this reason, the angle of, if the angle of incidence is greater than critical angle, in such a condition, so the ray is reflect back to the same medium, and so the person standing here, so which is appears like this object is reflecting back because of the some water is present there. That's why so this object is reflecting, and which is appears like to him. Scaled right angled prisms which are made up of glasses are taken to use as a the bend the light as a 90 degree, 180 degree like this. So to change the direction of light, we are using these type of isoscaled right angled prisms. So in which first one you can consider like this. Let us consider the isoscaled right angled prism. Here there are two small faces AB and BC and one larger face AC. Once the parallel beam of light which is incident on the smaller surface AB, that is without any deviation, and entering into the second medium, that is prism, like this, a parallel beam of light without any deviation that will travel to rarer medium into denser medium. Then once this is an incident on the larger surface AC, the angle of incidence is greater than critical angle. So angle of incidence here, this is an angle of incidence which is greater than critical angle. In such a condition, this ray of light that totally reflect back to the prism only. Again, so this ray is incident normal to the surface BC. So because of the normal, that is travel without any deviation, like that. The same concept here. The ray which is incident on the surface AC and the angle of incidence is greater than critical angle, hence that is a reflect back to the same medium and travel like this. And these type of prisms are used in periscopes, so to change the directions like this. So this is a one that totally reflected prism. Or next you can take it as a to turn the 180 degree. The ray of light can bend 180 degree like this. Once the ray of light which is incident on the larger surface AC, without any deviation, that will enter into the prism, and the angle of incidence is greater than critical angle here, hence that is travel back to the same medium like this, and which is incident on the another surface of the prism, that is another surface of the prism BC, and again this angle of incidence is greater than critical angle and reflect back to the same medium, and without any deviation that will emerging out like this. So this is another ray which is used to change the 180 degree. The ray of light, this is 180 degree changing its direction using this isoscaled prism. And this type of prisms are used in the periscope, and this type of prisms are used in the binoculars. So this is a one type. These are the prisms used to get the total internal reflection.